All right, so we're going to decide whether the given ordered pair is a solution to the given system. How are we going to find out if on 3A there, if 8, negative 9 is actually a solution to that system? I could graph it, but they didn't give me a graph.
Plug it in.
Yeah, plug it in. If it's a solution to the system, it has to make both equations true, doesn't it? So if you look at A, so there's my X and my Y, so I'm going to plug it in. So 8 minus a negative 9, is that equal to 17? Yeah, so 17 equals 17. So it's a solution to the, it's on the first line basically, but is it on the second line?
Yep.
So we have X plus Y, and we want to, is it equal to negative 1? And it is. So since it's true on both of them, then it is a solution. So y'all check B. If it's not true on either one of them, then it's not a solution to the system. It might be on one of the lines, but it's not a solution for the system, okay?
So what happens if one is only right?
If one of them's only true, then it's not a solution. So let's do B.
It's only a solution with the...
It's only a solution if it's with both of them. And so look at this one. This one's negative 13 is equal to negative 12. Is that true?
No.
No, so this one is not a solution. I didn't even have to check the other one. I did kind of look back over my work on this one just to make sure I didn't make a little mistake, including to make sure that it really did start with a 3, and I didn't miswrite the 3 there, because if it had been a 2, it would have worked. But, so I did double check my work on this one to make sure, but because it's not on that first line, it cannot be a solution to the system, because remember, the solution is where they intersect. It's the ordered pair that they both have.
You just
All right.
sub that John in.
So yeah, verse ones, they tell us to use the substitution method to solve it. So that's where you're going to solve for one of the variables, and you're going to plug it into the other equation. So number 4, they already did that. They already solved for one of the variables. They told us y is equal to 5x. So we're going to take that and plug it into the other equation. So the other equation is 2x minus y equals 6. And we're going to plug in, where there's a y, we're going to put that 5x. So 2x minus 5x equals 6. So negative 3x equals 6. So what is x? Negative 2. And once you know the x value, what do? Plug it in. But I already know, remember, that y is equal to 5x. So I'm going to plug that negative 2 in that. So y is equal to 5 times negative 2, which means y equals negative 10. And if I know x and I know y, then I think my solution is what? Good. Now, how can I make sure that that solution is correct?
Plug it in.
Yeah, I can do what we just did on number 3, right? We can plug it in and make sure it makes both of them true. And it does. All right, so did y'all get like negative 10 equals negative 10? Or maybe if you move some stuff around, you might have got like 0 equals 0, but you got a number is equal to itself, right? All right, so when you get this, a number equals a number, you got to ask yourself, is it true or is it false?
True.
It's true. What is it if it's true? What do you think? What's that? It's more than just a solution. It's infinitely many solutions.
I know that.
All right, so is this one going to be, it didn't ask us for it, but just so we're going over it, is it independent? Well, I guess which would be consistent, inconsistent, or is it dependent? It's dependent, right? because they're coinciding lines. One line's on top of the other. Okay, what about number 6? What do we need to do there?
You need to. I forgot already. You need to plug in. You pick which one you want to plug in.
Solve for a variable.
Plug in the bigger one to the smaller one. That's like the easier one.
Well, the easiest way to me, if you're doing substitution, guys, and it's not already solved, x equals or y equals something, pick a variable that preferably has a positive 1 in front of it. So I have this variable right there, right? That x. So I'm going to solve for that x. So we have x equals 2y minus 13. So now that I have that, I can plug it into the other equation. See, and we solved for x. I'm plugging in for x.
Why did I think that was a good idea?
39.
I'm not in multiplication. I skipped that whole entire year.
Did you?
Yeah, my old school was teaching us 1 times 2, and then I came to Huffman and we were learning long division, so I just skipped it all.
Yeah.
Oh crap.
Okay, once you know y, plug it back in to solve for x. I already knew x was equal to 2y minus 13, so I'm just going to use that. So x equals 2 times 5 minus 13. And your solution is going to be your x comma y.
Does it get any harder on this?
Well, we'll do other stuff with it. But, I mean, yeah, I could get harder as far as the substitution, because if I'd have had a 2 in front of the x, I'd have to divide everything by 2. I could end up with some fractions, different things like that, okay? So that's the only way we get harder. But the procedure's the same. You solve one equation for one variable, plug it into the other equation, get that number for that variable, and then plug that back into the other.
I feel like this is